Hello and welcome to Cyberside Chats. My name is Sherri Davidoff. I'm the founder of LMG Security.
And I'm Matt Durrin, the Director of Training and Research for LMG Security. And today we're going to be talking about how one weak app integration led to the breach of multiple different large-scale companies, including Palo Alto, Zscaler, and many more. A lot of them coming through things like Salesforce or Google Workspace or something like that. But the interesting thing here is that Google Workspace and Salesforce weren't actually hacked. We'll get into that here in just a minute. So,
That's
Sherri?
right. It was because of that third-party app that integrated with it, Drift. And you probably saw this in the headlines as yet another Salesforce hack.
Yeah.
But that's not actually what happened. This is similar to Snowflake, where the app itself wasn't hacked.
Well,
Salesforce wasn't hacked.
I mean, to be fair, this is coming right off the heels of a different attack against the Salesforce platform.
Yeah, so it was confusing for the public.
It was, and like even I spotted this as like the same attack, just like moving on at that point in time. But the first one was credential stuffing and social engineering that was used to authorize applications to access Salesforce data. In this case, attackers were able to hijack API keys for the Drift application because of some insecure configurations, and that basically becomes like their skeleton key into the Salesforce database at that point.
And this is really interesting because your security depends, in this case, not just on a third-party provider, but in this case, it's about the relationship.
Right.
So there's the Drift app, and there's how it integrates with Salesforce, and there's actually an intermediary, SalesLoft, as well. So originally I was like, oh my gosh, it's like a bizarre security triangle, but it's more like, what do you call it when it's four? Or actually, there's other parties involved too. Maybe it's a security hexagon.
It's a security pentagram at this point or something like that.
That would make sense.
Well, I mean, before we get too far into that, though, we should probably explain like what an OAuth token actually is.
Right, because that's what was stolen.
So yeah, and when we think of an OAuth token, I mean, when we have applications that are going to be basically logging into the systems that you use, we don't want to have them go through, and this comes down to convenience, we don't want to have them go through things like the username, password, multi-factor authentication, and everything else. And apps can't really do that, right?
They can't biometrically authenticate.
Yeah,
I guess you could have a stored password and enter that, but we all know that's bad.
So instead, we use an OAuth token. And an OAuth token is a uniquely issued token, a long string of letters and numbers. Think about it like a SHA-256 hash value. Like they're not easy to guess. Digital key. And that allows the application to then log in as whatever user it's been given the permissions of to that application. Now, it's great because it is a much easier and in most cases more secure way of logging into an application. But if that key is stolen, that means the attacker can now log into that application and have all of those permissions for themselves, and they don't need the username, the password, or MFA.
And what's so important about this is that this incident or group of incidents really hits on a couple of trends that we're seeing. Hackers are targeting keys. They're targeting tokens. They know that often these are backdoors into your infrastructure. And it really says something that these major organizations were hacked and attackers were getting into their Salesforce instances and also into Google Workspace instances and other platforms for, 10 days this summer, August 8th through 18th?
8th through the 18th, yeah. There was a decent time. And then, Google, I think, was the first one to actually report that they had noticed the behavior.
Yep.
But the thing that I really love to point out about these things is how often, and this goes back to like our penetration testing team, they find things like access tokens a lot when we're looking through networks. And it's because programmers will either insecurely design how those tokens are issued, or they'll hard code them into scripts or other applications that an attacker can identify and then just use at that point in time. And that's similar to what happened here. I mean, this was a problem between the SalesLoft middleware application, like the one that was integrating Drift into Salesforce, and how it actually created those tokens. So attackers were able to then find that. They were able to issue tokens on behalf of Drift, which then gives them all of those permissions.
The same permissions that the user would have to access all the stuff. And it's a chatbot, right? Like, what does Drift actually do?
Drift's like an AI chatbot. We should cover that too. Yeah, Drift is like an AI chatbot. It's something that, like, if you go to a website and you get that little pop-up that says, like, hey, would you like to speak to customer service? You can use something like Drift to automate that process. It has access to your Salesforce data, it has access to your customer information, so that can interact on behalf of your staff at that point in time. And a lot of companies are using that right now. I mean, AI integration is not like a new thing at this point. We're pretty familiar with it.
Yeah.
But again, that has access to like a lot of juicy data inside Salesforce because it kind of has to, and that's the problem.
Yeah, so with Zscaler, I know they exfiltrated customer cases.
Yep.
I know Cloudflare ended up rotating 104 compromised API tokens. That's a lot.
That had to take a while.
So, and there were, I think Drift also has email integration, and that was what was compromised in the case of Google Workspace.
Yeah, that was the Workspace integration, yeah. And again, I mean, these applications are meant to act basically as your customer service staff.
So I have to say, I think a lot of people are like, oh, meh, it's not social security numbers. Why do we care? But honestly, I don't care that much if my social security number's stolen, do you?
I mean, that is literally what I said earlier. Like, it's been stolen a bunch of times. But
the stuff in Salesforce can be surprisingly damaging and create a lot of systemic risk going forward. It's kind of like the frog in the pot of boiling water. Like, the temperature just keeps going up and up. But you made a really good point earlier about the compromise of the Dell customer service database several years ago. Do you want to talk about that?
Yeah, no, I'd love to. I mean, when we talk about that kind of information, so Dell's customer service database, for those of you who are not familiar, it wasn't necessarily compromised. They just had a kind of a weak request protocol that you could use, where if you made up a company name, you could request information back about customers.
So it was an information leak.
Yeah, exactly. And the information you were getting back wasn't like credit card information or your social security number. It was like your order date and the service tag of the PC you bought and how much you paid for it, or something like that. So
who cares that Matt knows what PC I bought? Well, it turns out Matt could use that to attack me.
I could.
Or really to social engineer me, because if you have sensitive information about somebody, or not even sensitive information, just information that helps people trust you, you can pose as Dell and say, this is relating to your order, the thing you just purchased.
Exactly. And if I have something as like unique as like the service tag that's on the sticker on the top, like people are going to buy that. They're going to believe it. And that's where this problem comes in. I mean, again, this isn't health information, it's not credit card information, but it is just, in addition to all the other information that's been stolen about most of us at this point in time, something that can be used to create a really accurate data profile for someone. And if we have that profile, we can spearfish someone very, very efficiently.
And we see over and over, after a breach occurs, typically there's phishing attacks that relate to it. Even if it's not because of the breach itself. Like, sometimes, for example, there's major organizations that have announced breaches, and then boom, there's phishing attacks saying like, hey, claim your, whatever, free gift card or whatever it is here. The hackers will take advantage of any opportunity.
They totally will. Well, imagine you're a Palo Alto customer or something like that. And I can send you an email that has the last date of your last customer service call, what that service call was, what the actual ticket number was behind it, what your problem was. Like, that's going to make you think that I am from Palo Alto because I have that information now. And I can probably talk you into giving me something like access to your network at that point to fix your problem. And that's where the problem really comes in.
Yeah, like when DocuSign got hacked and we saw that there was hackers dumped a list of DocuSign customer email addresses, and those were targeted with DocuSign-themed emails.
That one was pretty brutal, yeah.
So I know companies are warning people, they're warning their customers to watch out for follow-on phishing attacks now and other social engineering attacks.
Well, but at the same time, there's a lot of misinformation that's already come out about this story. And one of those is what happened with Google.
Right.
So there was a whole glut of news stories that came out where it was saying Google is advising all of their 2.5 billion members to reset all their passwords into Google at this point in time.
Not true.
Google has come out and said they did not say that. Yes. So if you're a Gmail user, if you have multi-factor authentication or you're using a passkey or something like that, I mean, there's a really low chance your password would have been compromised in a Google Workspace hack. They're two separate systems.
So how did that happen? Did some journalist just get the wrong idea from this technical jargon?
It was a journalist who released the story. It wound up on a bunch of tech sites. It got picked up by a bunch of other tech sites, and then it just kind of snowballed there. Like, what's the phrase that Roosevelt used to use? Like, misinformation can make it halfway around the world before the truth puts its boots on, or something like that. That's kind of what happened here. It wasn't necessarily a lie. It was just a misinterpretation of what the severity of the event actually looked like.
Wow.
So, yeah.
Well, it was an accidental lie, I guess.
An accidental lie. A lie of, well, let's not call it ignorance, but yeah.
But anyway, the bottom line is this is a supply chain OAuth compromise, and it's really hard to protect against because you're talking about multiple parties at this point. So how can we protect ourselves from this? Number one, make sure that whenever you can, your vendors are getting testing, security testing. Like you said, qualified penetration testing team could have found this. Would it have been easy to find? No.
No, probably not.
Absolutely, an experienced penetration tester could have found this.
Yeah, they could have found the weakness in the relationship between these two pieces of software.
Oh my gosh, I think Tom Pohl on our team would have had a field day with this one. Number two, make sure you're limiting your app permissions. We were talking about this earlier, but Often apps are over-provisioned to have more access than they need. So think about, what access does this app really need? Sometimes it does need access to your customer database, but maybe it's the type of thing you can limit. And if you can, you will also limit your risk.
Right. No, I mean, we need to treat these app integrations like they're a user on the network. I mean, if they don't need access to something sensitive, they don't get the access. I mean, we've talked about this with AI too.
I was just thinking that, yep.
Next up, we want to make sure, and this is just a best practice that you should be implementing anyway, but when you're using access keys for things like either APIs or integration, make sure that you're regularly rotating those keys. If you leave them sitting out there for too long, it's the same as keeping a password for too long. It just increases the risk. And yes, there is an argument that if a key hasn't been, or a password hasn't been compromised, there's no real point in changing it. But we've run into enough problems at this point where a key gets leaked, or it gets hard-coded into a script and uploaded to GitHub or something like that.
I think there's no harm in rotating.
No.
Especially, it's not like users. If you make users change their password, they're going to put like the number 1 at the end, or they're going to change the year, or they're going to change spring to summer. Whereas with service accounts, you can do a true rotation and pick strong new tokens.
Yeah. And they're going to be completely unique. They're going to be a secure way of accessing that account. And I mean, even AWS.
And there's tools to facilitate
There are. AWS is an example. I mean, they recommend rotating your keys every 60 to 90 days, so every couple of months. And they offer software and applications that can help you manage those keys, which is really nice. If you don't have to go through and manually do those key rotations, then that just makes things easier for you. Now, if you do have to manually do them, that's also fine. You just need to set aside the time, and it doesn't take that long to do. It's a fairly easy thing.
It should just be part of your checklist, everybody.
If
you have cloud apps and you have integrations, look at how you rotate those tokens.
Think about it like your patching schedule. I mean, you've already set aside time for that, and rotating keys is, again, a great way of securing those accounts long term.
That's great advice. Think about it like your patching schedule.
Yeah, there you go.
Monitor for data exfiltration from your cloud apps. Back in the day, the past few years even, people were monitoring from their on-prem organizations. So many people have just moved everything to the cloud, and we're really not seeing the same level of monitoring in the cloud.
That's true.
And we need to be. And that includes your third-party apps. You can monitor for exfiltration of data from Salesforce, and you can limit where that data goes as well. So no, you can't actually exfiltrate my data to North Korea. And if someone tries to do that, it should be blocked, or at least there should be an alert.
At least you should get an alert about that. And if you're using Amazon's S3 service, you can set up usage thresholds, which will show when there's a spike in network data or something like that. A lot of applications give you the tools that you need to identify when something like this actually happens. By the way, wasn't back in the day a Thursday? Pretty sure that's a Dane Cook reference, but we'll move on from that.
Well, let's wrap it up. I mean, finally, incidents happen, problems happen, and make sure you're integrating third-party apps and integrations. Integrate your integrations into your incident response plans. So think about what happens not just if the cloud apps you're directly using, like Salesforce or Google Workspace, are hacked, but also if there's a problem with a third-party app or a plugin that you rely on.
Right. I think the term I saw used for it was your incident response plan needs a SaaS chapter, basically.
Yes.
And I think that's a great way of going about doing that. I mean, when we send stuff up to the cloud, there's this misconception that it's natively just a more secure environment. And in some cases that might be true, but in most cases it's not. I mean, it's what do we like to say? There is no cloud. It's just somebody else's computer. Yeah, exactly. So we need to be treating that the same way we'd be treating our on-prem data, and make sure that you are prepared in case one of your providers like this gets popped.
Yeah.
I mean, it's not unheard of at this point. In fact, it's becoming more and more common.
Rotating the tokens that your app integrations use to access your cloud platforms is really key, and most incident response teams, frankly, are not trained on how to do that. So make sure you're including it in your training. Make sure you're including it in your incident response plans, because this is the future, and the future is here.
The future is now.
The future is now. All right.
All right.
Thanks so much for tuning in, everybody. Please like and subscribe, and we'll see you next week on Cyberside Chats.
All right. Thanks, everyone.